This section is about sampling means. So we're going to start straight away with an example, but I'm actually going to give you a few little things with it. So in this example, they tell us that SAT scores have a mean of 500 and a standard deviation of 100. I'm assuming this is one of the sections of the SAT. I'm also going to add that this thing didn't get put in the original question. They also follow a normal distribution. That's an important thing to know. We'll get to that in a minute. And so what do we expect the mean to be for a random sample of 20 students? I'm also going to add a follow-up question, so just keep that in mind as you're writing this. I'm just going to put that in right there. I'll just stick it right here. I'm going to ask you also, what is the probability that your sample will have a mean of over 550? So just make sure that you know that we're going to have a little bit more in this. Okay, so I'm going to give you a few things about sampling means. So the first thing I'm going to give you, so for sampling means, is that our sampling distribution mean, which I denote with the mu and a subscript of x bar, that is going to be equal to your population mean. Your standard deviation in a sampling distribution, which I denote as a sigma with an x bar, is actually going to be, and I gave you this formula before, the standard deviation, population standard deviation, over the square root of n, where n is the sample size. So this notation is among the most confusing that we get in this class. If it really bothers you, you can just write down mean, and you can write down standard deviation or SD if you feel like you're not going to be able to remember this. So that's the first thing that you need. The second thing that you need is that there are going to be several conditions. Now, I think you've heard most of them before, but I just want to reiterate two of them and give you one new thing. So whenever you do any sort of thing involving the normal model, you need to have randomization. Alternatively, you can have independence if there is no randomization. You also will need the 10% condition. And the 10% condition allows you to use the standard deviation formula there. The third thing that you need, and this is going to be different from the previous one, is going to be you need a large enough sample or you need a normally distributed population. So there's two possibilities. If they tell you in advance that the population is approximately normal or it's normal, then you're good. If they don't tell you that, then you need to have a sample size of at least 30. And now if you're like 29 or something, usually that's okay, but a rule of thumb is usually going to be 30 or a normal population. So we always have to check these three conditions. So that was I got a little sidetracked there, giving you a few things. So now let's get back to this problem. So they tell us that SAT scores have a mean of 500. In this case, that 500 is our population mean. They also tell us that they have a standard deviation of 100. That's our population standard deviation. Then they say, what do we expect the mean to be for a random sample of 20 students? Actually, this one's really nice. What we expect the mean to be for a sample, our sample mean, would just be the same thing as your regular mean. So now that question is not like that involved. So that's why I added the second question. So I asked you, what is the probability that your sample will have a mean of over 550? So I'm going to call these A and B. So this first thing was A, and then the second question is B. This one's a little bit more involved. We are going to be using a normal model, but before we do anything, we have to do our conditions. You must check those. So from here on out, you should be checking conditions for almost everything. Okay, so my first condition, they specifically tell us that this is a random sample. So we're good on that one. Our second condition is the 10% condition. Our sample size is 20. 20 is definitely less than 10% of all people who take the SAT. The last thing is our either normal or n is greater than or equal to 30. So in this one, we actually don't have a big enough sample size, but luckily they tell us, or that I added, that the SAT scores follow a normal distribution, so we're good. So the population is normal. So because all of these things are true, we are allowed to do what's next. If they were not true, you wouldn't be allowed to do that. Okay, so now we're actually going to find this probability. So we are going to be looking for the probability that in our sample of 20, our sample mean is more than 550. And we're going to do that using we're going to use a normal model. We're allowed to do that because of our conditions. And our mean in this normal model is going to be 500. It'll be the same as what they gave us before. And you also got that in A. Our standard deviation is a little bit more complicated. Be careful. Make sure that because we have a sample of more than one student, that you do that formula that we have. So our standard deviation is going to be 100 divided by square root of 20. So that was this formula right here. That is going to give us 22.36. So the last thing that we need to do, and I'm running out of room here, so I'm going to just draw my normal model up top. We are going to use a normal model centered at 500, and we're going to find the probability of being more than 550. To do that, we will just do, you can do it on your calculator. You're going to do normal CDF of 550, any big number after 550. By the way, be careful, make sure that it's big relative to 550. If you use like 900 or if you use like 99 or something, that's definitely not going to be bigger. Then we're going to use a mean of 500, standard deviation of 22.36. That's going to give us 0.013 or 1.3%.